can assume that, so you see, like, we don't have any positive feedback, we only have a negative feedback, so we can assume that these two voltages are the same. Let me call this one VP and this one VN. And these two currents are also 0. Okay, so let's first look at this part, right? If this current is 0, then we basically have a voltage divider. So can I derive VP in terms of V1? Yeah, it's just like basically a voltage divider. So it's going to be R2 divided by R1 plus R2 times V1. Okay, and for this one, again, I'm just going to write KCL at this node. Because there's no current going here, means that the same current that goes from V2 to this node, it's gonna go through R4. So let me write that KCL. I'm just gonna write Ohm's law for this resistor and for this resistor. So V2 minus VP, VN. But we also know that VN is equal to VP, right? So instead of VN, I'm just gonna write VP divided by R3 is equal to this voltage, which again I can write VP minus V out divided by R4. Okay, let me put VO on one side. VO times 1 over R4 is equal to, I'm just going to factor out VP. VP times 1 over R3 plus 1 over R4 minus V2 multiplied by 1 over R3. Okay, excuse me. So I'm just going to simplify this again. I'm going to replace VP by the thing that we found. So VO times 1 over R4 is equal to V1 times R2 divided by R1 plus R2 multiplied by this term, which I can write R3 plus R4 divided by R3 times R4 minus V2 times 1 over R3. Okay, now if I multiply both sides by R4, we have V out is equal to V1 times R2 divided by R1 plus R2 multiplied by R3 plus R4. These R4s are going to cancel, so R3 minus V2 times R4 divided by R3. Okay, so this is how our output voltage is related to our input voltages. And you can see that our output voltage is a multiple of V1, which is connected to the non-inverting pin, minus a multiple of V2, which is connected to the inverting pin. And by choosing R3 and R4 and R1 and R2, we can make sure that our output voltage is whatever we want in terms of V1 and V2. So for example, if this is what we want, you can see that you can choose all of these resistors to be the same. If that's the case, if you choose all of these resistors to be the same, what do we have here? This becomes 1 over 2 multiplied by 2, it becomes 1, and this is 1. So we end up with V1 minus V2, right? So, and it can be any number, 1 ohm or 100 ohm, as long as they're equal, So this would simplify to this form. So this circuit is called subtractor, and you've seen this one before as well. Okay. The next circuit I want to show you. So the reason op-amp it's called operational amplifier is because you can do arithmetic operations with it, right? So like you see that you can do subtraction, and now you're gonna see how we can basically use it as an adder or summer, like if some people call that adder or summer, I'll call it adder. So you can use it to add two voltages, two signals, or excuse me, or to subtract signals. So let's see how we can use op-amp as an adder. So again, we are gonna have a negative feedback. If we don't have negative feedback, op-amp gets saturated. So that's why we have to have a negative feedback. Let me call this one RF, F for feedback. Let me ground this one. And let's assume that we have three different input voltages. Okay, so I'm just gonna call this one R1, R2, and R3. Okay, and I'm just gonna connect them together here. And this is connected here. Okay, so again, because excuse me, because we have negative feedback, op-amp can make sure that this voltage and this voltage are almost the same as long as our output voltage is between these two power supplies. So because this pin is grounded, its voltage is 0, we're gonna have a virtual ground here. Okay, now these two nodes are basically the same, they're connected here. So if I write KCL at this node, it means that this current plus this current plus this current, it's gonna be equal to the output current. So basically, let me call this one I1, I2, I3, and this one IF. So KCL tells us that sigma IN is equal to sigma I out, or in this case, I1 plus I2 plus I3, it's equal to IF. So now let's write Ohm's law for each of these resistors here. So for this one, I1 is V1 minus 0 divided by R1. So I can write V1 divided by R1 because this one is grounded, plus V2 divided by R2 plus V3 divided by R3. It's equal to negative, because it's going to be 0 minus VO, so negative VO divided by RF. So that means that VO, it's going to be negative, I actually write it like this, V1 times RF divided by R1